Am I here? Uh, oh, the timer fired early. I see what happened. I see what happened. Okay, I think I'm here. Yeah, this all went pear-shaped because OBS failed to connect to YouTube because they were having disagreements about the stream key. So then I had to switch to account-based authentication, and anyway, I had to reconfigure the stream like 3 minutes before going live. Good morning, everybody. Which means, no, I'm not here. That's right. I'm a figment of my own imagination. Or somebody's imagination. I don't know. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Okay, quitting out of that, and I think we're here. None of us are here, says Crispian. So, I'm just going to check whether CastNote has caught up. Does it think that I am streaming? Maybe it doesn't know about this stream. Streams? Yeah, okay. TTS. Oh, streaming now. There it is. It's out of order. For some reason, it's just reordered everything. Here we go. Good morning to Princess Fiona, Stephen George, David Crisp, Crispian, Henrik, and good morning to Grant as well, and Tinker001, John Whips, Tech Nebulous, Stephen44799, Russell Rennie, and coming all the way from over the pond, Vic, our benevolent overlord. Gavin, we can confirm your existence, or can we only... it's whatever your senses are telling your brain, or whatever your brain is perceiving. That's as close as we get to reality. Yeah, so... let's see if this works. Overhead camera... Oh, I've got to turn that camera on as well. Okay. I have a few things today. We are going to start with kicking off a 3D print, then we are going to slide back on over to here to do some stuff on this, and then, and this, and play around with this, and maybe with this, in fact almost certainly with that. But first, back to here. What are we doing? Oh, okay. Also, good morning to Gavin, Paul Schultz. I will return to Paul in a second. Simon CBR and Imi. Yeah, so Paul very kindly sent me this. It's not a bag of coins, despite what it may say. It is a microscope calibration slide. Microscope micrometer calibration ruler, which is really cool. In fact, I'm going to start. Let's start with trying to get that set up. This is it. So, Paul, thank you very much for sending this. I was talking about these on a stream a couple of weeks ago, and just got to clear some space under the microscope. Ooh, putting it on the dirty bench. I shouldn't do that. What I'm going to do is put it on a stack of Post-its, and we're going to switch to the microscope in a second and have a bit of a look at this calibration slide and zoom in as far as I can. Is the brightness at max? I think the brightness is at max. It is. And where's the button? Where's the button? That one. See if the microscope is running. It is. So this is looking at the microscope calibration slide. You can see the center of an X there. This, where is it? So there where it says 0.03 millimeters, slide left, that line is 0.3 millimeters wide. I'll see if I can fix the focus a bit. There we go. So that's a 0.03 millimeter wide line. Then we've got 0.05, 0.07. Let's go to 0.1 of a millimeter. So that one there, which looks quite large and chunky, that is 1/10 of a millimeter wide. And what else have we got on here? Grid. Okay, so grid shaped. Division is 0.1 millimeter by 0.1 millimeter. So this is a grid. Once again, I've got to fix the focus. I'm on maximum zoom on this microscope right now. We could probably switch to the USB microscope as well. That'd be interesting. You can see the artifacts from the limits of resolution of the printing that they can achieve here. There are some little dots and things. But that is pretty impressive that they are doing printing on this sort of scale. So those numbers across the top, those are millimeters. And then the graduations within them are 1/10 of a millimeter. What else have we got on this slide? Down here somewhere, inch. What are we doing with inch? Okay, I'm going to skip straight over that. There's a millimeter scale here. 0 millimeters. So I think those are that's 10 millimeters. Okay. So the large ticks are 1 millimeter, and the little intermediate ticks are 0.5 millimeter. I'll see if I can. Is that it? Yeah, that's 5. Yes, that's right. So that to that, it's hard pointing at this scale, is 1 millimeter, and these intermediate lines are 0.5 of a millimeter. Oh, and there are some circles. More interesting things on this line. Round shaped. What are we doing? Looking at unit micrometers, diameter measuring tape. Okay. Particle. Oh, round shaped particle diameter measuring tape. That's interesting. All right. That's what the purpose of this is. So these circles, that little dot that you can see there, that is 100 microns. It's 200, 300, 400, etc. 800, up to 1,000 microns. That huge one there is 1 millimeter diameter. And then, yeah, it gives you a sense of the scale that Vic is working at now. It's kind of crazy. That big one is 1,000 microns. Scale all the way down here to 100 microns, and that scale is enormous compared to what Vic is working at. So with the RepRapMicron, he's now messing around down in the 4 micron range, 4 micron resolution, and we are looking at 100 microns under a microscope, and it looks like a dot. Yeah, kind of crazy. Later I'm going to have the USB microscope connected, and we are going to have a good look at this. So, what are these graduations? That's 5 millimeters. So that's 1. Yeah. So these must be 1/10 of a millimeter spaces on there. So these are 100 micron spacing on this ruler. Okay, yeah, so as I said, this little calibration slide was sent to me by Paul. Thanks, Paul. I really appreciate it. That's very cool. And I think Paul is building his own RepRapMicron at the moment as well. I'm pretty sure I've seen some references to that along the way. Tabraze is here too. Welcome to Braze. And okay, time for me to check out the chat. Yeah, we're Vic says, yeah, photo processed glass slides are better. Under 16 bucks, go down to 0.01 millimeter. Yes, I wouldn't even be able to see that with that microscope. So that's the trinocular microscope that I normally use for electronics assembly, and it's not super high resolution because you don't actually need really high magnification. You don't really need high magnification for electronics assembly because you just don't want it. You need to be able to see enough of what you're doing that it takes up a good part of your view area, but you can't be zoomed in on like one tiny part of a solder joint. You want context. Yeah, but the other microscope, the USB microscope that I got to put over the RepRapMicron, that has a higher magnification. So we'll mess around with that and see how that looks in a little bit. Tinker says, at what version will there be a need to swap that onboard microscope for an electron microscope? I'll go straight for AFM. What is AFM? What's that acronym? Okay, AFM. I am searching for it. Oh, atomic force microscope. Okay. Yes, I've heard of those before, but yeah, I didn't recognize the acronym. Yeah, atomic force microscopy requiring an electron microscope does increase the cost floor somewhat significantly, says Stephen. Yeah, it does. A little while ago, oh, maybe 2 or 3 years ago, there was some facility just north of Melbourne, I think, I can't remember where, that had a decommissioned electron microscope for sale. And word went around the hackerspace and a couple of other places, and it was one of those situations of, oh, this would be such an amazing project to grab hold of that and then and try to recommission it, get it back up and running again. But it's also one of those projects where you need a serious amount of domain-specific knowledge, which you could acquire along the way. But it's, yeah, a big project with a very a large and complicated piece of equipment with interesting things required to make it run, to get the temperature stable and all of those sorts of things. And then what would you use it for? It's getting down into the scale where you're looking at things that kind of doesn't even make sense to look at in that way unless you have a very specific application for it. Oh, Grant says, we have an electron microscope in the lab at work. I think the attached PC runs Windows 95. Yeah, that sounds right. $250,000 to upgrade the software. Yeah, that sounds about right too. Yeah. Electron microscopes and atomic force microscopes are those things that you think, oh, it would be so cool to be able to see things at that scale. And then the reality of it, unless you were really obsessive about it, it is not the sort of thing that you can really justify having sitting around in your workshop. You need a need, or you're not going to get anywhere with it. A bit like the Garage 54 guys trying to start a helicopter turbine they shoehorned into their Lexus. What? Okay. It is not used much, hence no software upgrade. Yeah. What's news? What's news? I wasn't here last week, was I? Ooh, Applied Science built his own. No, I'm not going to look. I'm not going to look. Error, too many projects. Is it last weekend that I was in Canberra? Or was it the weekend before? It feels like weeks ago. So long ago. I'm genuinely sitting and puzzling right at this moment. Whether it was only last weekend, says Stephen. Yeah, it feels like so long ago. Not just a matter of days. All right, yes. And Crispian confirms. So, last weekend, I was a +1 for the Linux Australia face-to-face. I just went along. I was not doing any LA business. There were reasons. Reasons to go. Personal reasons to go. And yeah, it was a very nice weekend. Got to see a few people that I know through Linux Australia, which was great, and got to meet a few of Princess Fiona's friends, which was awesome, including people I've known for some that I've known for quite some time. Yeah. What am I looking at? Okay. I am going to step one. I need to open a terminal, because you always need a terminal. Yeah, so the upshot of all of that was that while I was in Canberra and Princess Fiona was doing official business, I was sitting there with my laptop doing stuff, and did a few things. I did a thing. What am I going to do? I'm just going to show you this before we do this. Do the thing. What am I going to do? Git pull. That'll do. Because I made some changes just last night, which were on my laptop, and I pushed them this morning, and then they're not on the local machine. Okay. Vin activate. In your sources, activating your vents. Get the right key, please. Migrate. Go. Do it. Okay. Now, let's do this. Run server. Do it. Run. Oh, come on. Why no autocomplete? Run server. Run server 9. And I'm going to have to be a little bit careful about what I click around in here, because I do not want to reveal things that should not be revealed. So I'm going to bring this up. Yeah, so this is Testomatic kind of related stuff. I'll bring it where? There, that'll kind of do. Yeah, so this is the register for storing device serial numbers and test results and all of those sorts of things. And over the last couple of weeks, it has started growing ERP and CRM functionality as well. So I've already shown you a little bit about this, and so it now shows the rendered previews of the boards. It's got all of the referenced design files here, bill of materials, which is a critical thing that you will see in just a second. You can see the details of the specific units that were built of that design, when they were built, etc. And I'm sticking with Superhouse projects here because there are also customer projects in this. This is just my local dev environment, but I've been messing around with it and loading things out of the spreadsheet of serial numbers. So yeah, with Fusion Extractor, you can upload the Fusion Electronics project. It then extracts all of these things, and it generates the bill of materials. And if we look at that, like if we click on it and download, oh, it was already, if I do this, what's it going to open in? Let's find out. Probably something inappropriate. Oh, numbers, close enough. Yeah, so this is the CSV, which is the bill of materials that was generated out of the air quality sensor, which is a design from a little while ago. And you can see, for example, the library column, and you can see there's a discrete semi row in here. There are a couple of discrete semi rows. That'll be significant. Resistor and cap are both coming from the discrete semi library. And since I did this design, I split that. So I now have Superhouse resistors, Superhouse capacitors, and a couple of others that came off discrete semi. So bill of materials is there. Now, if we go to, I'm not going to go into organizations, there is now also a settings area, so you can define production stages, and these are all of the possible steps that that we can go through in creating a circuit board. And these stages are used as building blocks, so you can just arbitrarily add your own stages, whatever you want to do. And then if we go back to settings and production stage templates, there are lists of production stages. So this one, for example, the basic single-sided load has these production stages. And if we go back to here and go double-sided load, it's got bottom SMT assembly, top SMT assembly, through-hole assembly, etc. And then the high reliability loads add stages like conformal coating and glue. And then, and these templates are editable and they get applied in a little bit. So what we can do, for example, is go into batches, and I can say, I want to add a new batch, and I'm going to make it, where's the, oh, okay, it's alphabetical. So I'm going to go air quality sensor, because I've been using that one. Say it was purchase order 1, 2, 3, 4, and I want to build 20 of them, and I'm going to apply the single-sided load template, save. So we've now got a production batch with all of these stages, which can be marked as started. So part stock, okay, we've ordered the parts and we've ordered the PCBs, so those are now in progress. You can put stages on hold. Once the parts arrive, you click that, it marks it as done, so that's the timestamp for that stage being completed. And then PCBs arrive and you click that one, and now that's marked as completed. And then we begin top assembly and then finish top assembly. Keeps all the timestamps for the stages at which this batch was done. You can customize this list on a per batch basis if you want to. So if we come back to here, you can see that this is the one we just added, and it's got 8 production stages, created 21st of June. So a whole lot of batch management stuff in there. Also part management. So in here it's got, you know, audio, capacitors, diodes, that sort of thing. And if we come into, let's find one. This one will do, like a G5, no, I'll find one that's got multiple suppliers. Where is one with multiple suppliers? Maybe an INA 260? This one's just got DigiKey. So these are sources and links to them, stock on hand at DigiKey, and packaging. You can have substitutions, file attachments, and this gets auto-populated. So if I come back to parts, and these are uncategorized ones. You can do an import, populate from a bill of material, so you can pull the bill of material from one of the designs you uploaded and it will auto-populate. It'll add parts into here and dedupe. So if the parts already are in here, they will not be added again. There are also filters that get applied. So if we come into, and also there's a location management system for storing locations of stock and parts and assets, like where is that feeder, that sort of thing. We've got part categories that's all editable. Part import filters, so exclusion rules. I've got a rule that says do not import test points coming out of superhouse connectors, do not import fiducials coming out of superhouse symbols, so they just get excluded when you do the bill of materials import. Transformation rules. So in this case, what I can do is, if I've got, if I have a part in a bill of materials which is listed as 100 nanofarad 50 volts, it transforms it to 100 nanofarads and then does its dedupe, so that you don't get two parts that are otherwise identical but just have slightly different things. So that is to clean up matching. Library settings, you can have it dump values, because when you have a connector, you typically assign a value to the connector, but you do not want to dedupe including the value, because the value will be different for each time you use it, even though it's the exact same part. So you don't care about that from a quoting point of view. So you can apply a rule, for example, anything that gets imported from the Superhouse Connectors library, ignore the value. So you don't get your parts database polluted with 500 entries for the same connector. They just have different values assigned to them because they're used for different things. So all of these transformation rules, they're all working and done. So if I go to, and I've got client APIs now for DigiKey, LCSC, Element 14, all working. I've got one implemented for Mouser, but Mouser has a problem with their system right now. So if I come into, say, 4.7 microfarad capacitor, and you can see that I have possible suppliers of this DigiKey in 3 different forms, LCSC, and over on the right here there's a little refresh. So you can see here that last time this was refreshed there were 102,600 of these in stock at LCSC. So I'm just going to click refresh and we'll see what happens. It's connecting to LCSC. Oh look, it's just changed the stock quantity to 103,935, and it's also pulled down pricing information. That was the change that I made last night, was adding pricing with tiers. So you can see it's got price breaks at 550, 150, 500, and so if you buy a single it's going to be 60 cents, and if you buy 5 they'll be 60 cents, if you buy 50 they'll be 54 cents, etc. So you can see the price breaks there from LCSC based on their current pricing, and that all just got pulled down right then when I clicked that refresh button. And that could be done on a schedule, so all of your supplier stock levels and pricing could be updated periodically. Tinker says, is there nothing in the design information to indicate whether the boards are single or double-sided? You could check whether there are parts in the assembly file. Short answer is potentially yes, but you still want to decide whether it's going to be a regular load or a high reliability load, which might require using, say, sulfur resistant parts and conformal coating and glue and those sorts of things. But the design itself doesn't change. And all of this gets populated automatically as well. So in parts, I'm not actually going to do this now because I don't have one prepared, but if for example this was a new part that got imported and I wanted to pre-populate the image and everything else, what I could do is go into supplier SKU, put in the part number, click the name of the supplier, it will then connect to that supplier's API, pull down all the information including the picture, stock level, pricing, the manufacturer SKU, the packaging type, and the URL of the thing, and enter it all in here as a source. So you can do that and have multiple sources. And then there are part substitutions. For example, this is something that I just added. This is the change that I just committed this morning, which is, actually, here's a cool example. This is something that I need to resolve. There is a data issue here. So it's XF506P. I've got multiple records here at the moment for fuses where I've got, where were fuses? So I've got a 10 amp, a 15 amp, etc. I need to rethink this, but for now what I'm going to do is I'm just going to put a supplier SKU in here for, this is the LCSC number, and then I'll click go and we'll see what happens. So it'll add a record saying that you can buy this part from this place. So now we've got the supplier, this source record with the URL to the product. So if I click on that, it's going to take me to that. And it has also pulled down their price breaks, their current stock, and you'll see that it's also automatically populated the description. Oh no, that was populated before. It only populates if it didn't have anything. It's added the photo, which it pulled from LCSC. So this has all just been mucking around over the last couple of weeks with adding features and things. So the register is growing all of this ERP style functionality, which means that so one of the next stages is if we come into batches and we wanted to build one of these and we say we want to build 20, it can pre-assign serial number. On. Oh, it is. It just worked. Disk Maker, welcome. And that was Crispian who said that, but I just saw that Disk Maker was there. And yeah, it could pre-assign the serial numbers so that when, and then send the print job to the brother label printer so that the serials can get placed on the board. And it could also check stock levels. So we've got, what we do not have yet in parts is stock on hand. That's one of the next things to add. I need to keep track of stock on hand, like what reels I've got, etc. And then it could, when you say I want to build a batch, it could multiply out the bill of materials, because it's already got the bill of materials for this design, against the stock that matches it, and tell you if you have enough stock and any shortfall, and then where to order that shortfall. And it could then mark that stock as committed. So you might have 100 of a particular microcontroller here.
Asks, what database are you using?
Right now, what you're looking at here, this is running on localhost. This is just my local dev installation. This is running on SQLite, but it also runs on MariaDB. So the installation that I've got running, so I've got 5 installations of this right now in different structures. There are 2 running on Linode VMs, and they are running MariaDB. So the idea is MariaDB for production, SQLite just for quickly running up a local copy so that you can mess around with it and do dev. So you create a batch. You might have 100 Vroom modules, for example, and you say, okay, I want to build 20 Air Quality Sensor Pros. So now it would mark 20 of your Vroom modules as pre-committed for a batch, which means you've got 80 left of stock, even though you physically got 100 still sitting there. And then if you then needed to order a batch of if you ordered something else and it came up with a shortfall, it would know that there is a shortfall, even if they are not actually used yet. They might be on the shelf, but they've been pre-allocated or pre-committed to a batch which is in the system. Yeah, so this has basically just been a whole lot of fun messing around with this. What else? There's more. There is more in this. There's more stuff in organizations. There are things in places in here I can't really show you right now, because even on my test installation, which is this one, it's got real client names and real client projects and things in it, and I just need to be careful where I click. Yeah, so 6,500 boards now. Nice. Yeah, these numbers are real. 8, 167 and 6,592. So there are records in here for 6,592 boards that we have assembled. You need a stream safe data test set, says Stephen. Yes, that's right, yes. Princess Fiona was just talking about that yesterday, saying that we can use factory methods in Django to pre-populate the database, and yeah. Safe? Jono never plays safe. Yeah, test in prod. But we'll probably need to do a little bit of tweaking of the rules that it uses to generate the dummy content, because if you look in things like parts, there is a field here which is name, and if you tell the what's it called? Data boy? I think it's Data boy. Maybe. Yeah, if you, I'm going to call it for now until I'm corrected. If you tell Data boy to generate test record, like dummy records, it'll look at name and think, oh, that's a name for a person. So it'll auto-generate a dummy human name to go into that field. But that would not necessarily be appropriate for this. So there needs to be a little bit of tweaking. But what we can do is get it to to generate dummy content that is then safe to let people play with. Factory Boy, that's it. Thanks, Princess Fiona. Yeah, so Factory Boy generates the dummy data. NMAE. May. Paul. Okay. So, yeah. Oh, and where is, I'm gonna try loading something off screen just in case. Okay, here we go. Yeah, so this is the repo for it. For anybody that's interested in messing around with this, this is now public. Name, any Warhol factory ref. Yep, names could work if you're making products for IKEA. Yeah, Paul, you're correct. There should be an IKEA naming mode. All right, I'm going to drop this in the chat. This repo is now public after a whole long time in a kind of semi-stealth mode. Oh yeah, 10 hours ago. First pass at pulling in pricing data from suppliers. I thought I pushed stuff this morning. No, it was last night, that's right. Actually, technically it was this morning, but it was after midnight. First pass at pulling in pricing data from suppliers. So yeah, if you want to check it out, play around with it, the register code is up, the repo is public. I need to put a link to this from Testomatic because it wasn't public previously, there was no link from testomatic.io. But I will add one. And where are we? So, issues. Ooh, add pricing information retrieved from suppliers. So what I've done is I've only implemented the pricing information for LCSC so far. That was just a quick test so that I could get price breaks into the system and see how functional it is. And I'm really not that happy yet with the display, the way it works with that tooltip. But it's a first pass. It's a draft, and then I can add support for DigiKey and the other suppliers. Right now, it only pulls pricing information from LCSC, and you can see all of the other things, and you can also see a whole bunch of closed things, like add support for part substitutions. Oh yeah, I didn't even show you that, part substitutions. So say, for example, you specify that you have a 10K 1% resistor in your design, and a possible substitution for that would be a 10K 0.5%. So maybe the specs are better, it'll be a direct drop-in replacement, you won't get any downside for it. It's just, might cost a little bit more. So in the register now it has support for part substitutions. If you go, in fact, if you come into parts, I don't know, I'm going to pick this one and then I'll say possible substitutions. This is not actually a possible substitution. Let's pick a really bad one. All right, I'm going to pick a 0 ohm resistor as a possible substitute for the transient voltage suppressor, which is going to be a dead short to ground. So that would make your product go bang. But yeah, so sources we've got here, and then we've got possible substitutions is this part. And then this, what we could do is say, okay, we do not have stock of this one, but we do have stock of this possible substitution. But I'm going to delete that substitution because a 0 ohm resistor is not a replacement for a transient voltage suppressor. Yes, where are we? Yeah. So, if you have ideas, if you want to play along at home, if you want to, filters and transformations when importing. So in the closed issues, you can see a bunch of things that have been implemented. Like you can see 17 hours ago, 3 days, 4 days, 4 days, 5 days, 2 weeks ago, 3 weeks ago. all of these recent changes. It's been a whole lot of stuff done. Yeah, come along, play. Any suggestions or pull requests would be appreciated. Ooh, Grant says AliExpress order just arrived. Yeah, Stephen says it does suppress voltages though. Yeah, suppresses them real good. Up to its 1/10 of a watt possible rating. What would go first? The trace on the PCB or the 0 ohm resistor? I suspect the trace would go first because the 0 ohm resistor would be able to dissipate more energy. Okay. Oh yeah, this is just the running, my local running server. Let's kill that off. Bye-bye. Bye-bye register. Why not both? Both is good. Yeah. Oh, Don S is here as well. Welcome, Don S. And Imi Amelia. Welcome. Okay. That's right. The reason I opened the terminal in the first place is... I'll bring it back up in a second. Don't worry. Where is projects and RepRapMicron and CD RepRapMicron. Bring this back up now that the display has been sanitized. And let's see what Vic has been doing. Pika Touch Probe, .scad, microscope clamps, the README has been updated, Pika XY has been updated, and the reason that I did this is I'm going to go to here, RepRapMicron, and here, and where am I looking? Pika. Looking in the Pika frame trio. STL. So I want Pika XY. Does that open with OpenSCAD? Yeah, I know. It's probably OpenSCAD. Probably. I still call it OpenSCAD. Oh. Support ending for Intel-based apps. This version of OpenSCAD will not open in a future release of macOS. I will have to check for a newer version of OpenSCAD. Pika XY.SCAD and here. Yeah. So somewhere up here. Sheet number. Okay. Prints all the other bits. 2. What does 2 print? Let's find out. Preview. Yes, this is what I want. Okay, this part here is the part that has been updated. So you may remember from previous action-packed episodes, this is the part that I had printed previously, and the spacing on the holes was not quite right. And so Vic very kindly has updated it, and you can see this is the updated version. I'm going to go render. Is that render? I don't know. And I only need to print the rendering. Yeah, I only need to print the center plate. I don't need to print the outer support. Ba-ding, there we go. I only need this bit, not this bit. But I'm just going to dump it out as STL. STL. Dropbox. No, I want to go to 3D printing. There, RepRapMicron, wherever it is, RepRapMicron, and I'm going to call it. What is this part called, Vic? The bit that sits on top and has the UV LED, etc. Sorry, I got to mute for a second. Stage. Thank you, Vic. So I'm going to call that just stage dot settle, and then I'm going to send this to the printer, and then we're going to attach stuff on the picker while this is printing. So I don't think it takes. Server is unable to respond. What? Login information expired. Please log. What? Why? Come on, Bamboo. Why are you making me log in? New term, and extract my Bamboo password from my super encrypted thingy, and I will see if I can log in to use my printer. Why do I have to log in to use my printer? Yes, I know. It is a trade-off that I have consciously made. Do you want to synchronize your personal data from Bamboo Cloud? Yeah, sure. And that is the trade-off. Yeah, all my stuff being kept synchronized and being able to push remotely to the printer and all of those things. Okay, I am selling my soul for convenience. So, prepare, and add. I want to do RepRapMicron. This will come back up on screen in a second. Pika, stage.stl. There we go. Stage.stl, and then I want to do split to parts. To that, and then I can, nope, that didn't work. All right, I'll do split to objects. Does that work? Yes, and then I can delete that one. I'm left with just the stage, and I'm going to print this one in, I think I'm going to print it in blue.
At Vicoliver said, is the print bed clear?
Very good question. Yes, it is clear. We can verify that. I had something printing when I left yesterday, and then I pulled it off the printer this morning, and Cyclops is there watching. Prepare. Now, in terms of strength, there are a couple of changes to make here. Wall loops, I think, was up to 3, and top shell is on 5. What have we got? Bottom shell, I think, goes up to 5 as well. That seems about right. Is it missing an eyebrow? Maybe. Oh, I'd have to start the camera again. Wall loop 3, I think that'll do. I think that's the sort of strength settings we need. Support is off, which is what we want. That's all fun and games. Yes. Okay, let's see if TTS does Tinker's thing. And slice and dice, 47 minutes. Yeah, we'll see. We will see that.
It's all fun and games until the printer loses an eye.
Yeah. Hopefully, so this is going to be a dark coloured stage plate sitting on top of the yellow of the picker, which will make it really obvious where the stage plate is, rather than a simple, yeah, okay. Here it comes. I need a drink. Do you need a drink? Can I get you a drink? Would you prefer hot or cold? Or room temperature? What do you feel like? I don't know what I feel like. I had a coffee this morning, and I feel like another drink. Okay, so that is getting underway, printing the stage. Beer, please, says Tinker. Yeah. Stephen says John is getting a Long Island iced tea. I am not one for the alcohol. Okay, so next thing is, let us. Okay, I am going to bring up Session Buddy and find, see if I've got a thing open already. Probe chip fabrication and assembly, mouse access driver construction. There it is. This is the one that I want to open. Right. Yeah. Yes. Okay. Now, one thing that I have not done is the limit switches. I've got all the stuff here. So I kind of skipped over this part. And then I went to doing all of this and assembling that. We've done this. We've put all the nuts in there for all 3 axes. Those things, do they have? No, those other ones do not yet have the loom bands on them. So there is some assembly that could be done there. What I was thinking of doing was either attaching another stage, or attaching, no, not another stage, another access driver, or doing the limit switches. And I think I'm going to attach another access driver so that we can drive things around in 2 dimensions instead of 1 dimension. Which one should I use? I'm going to use green for green for y-axis. It is not an entirely arbitrary choice. It is slightly arbitrary, but it's based on the fact that right now there is a threaded rod in that one. No, but I could do the yellow. Oh, but if I do yellow, it'll disappear into the pica. I could do yellow for the z-axis. I think I'll do yellow for z-axis, and I will do green for the y-axis. Oh, Vic says, you need the stage to hook up the access driver. That is correct. Yes. David says, yes, I forgot to clear the print bed last night, and today I'm making a new z-axis stop adjustment lever number 3. Oh, 3.1. This is the real one today on the lathe. Ah, okay. Yeah, but what I can do, Vic, I think, is I can connect. Let's look at this, not just have me talk about it. Go to here. Move that out of the way. So we have the x-axis driver on here, and the stage will sit there, and the stage, all right, it's not quite the right one because the spacing isn't quite right, but this will show you the idea. The stage going on like this, no, like that. I had it upside down. That would have gone well. You can see the 3 holes here to match these, and then that sits on top like that. So this point up the top of the screen right here, this is where the y-axis driver mounts, and it pushes that way to move the stage in that direction. So I think what I can do, maybe I'm wrong, but I think what I can do is mount this. Oh, okay. Oh no. Yeah, that works. What I can do is mount this. Which way? I think it goes on this side, like this. Mounts on there approximately, coming in from the top left, and then this part here is what attaches to this part, but on the proper one. So there's going to be a blue one of these coming off the printer in 46 minutes. So what I can do is mount this onto the pica, and then when the stage is printed, I can put it down in here and adjust it. No, that way. It goes on the outside of that mounting plate there, and screw it on. So I don't think not having this stage will stop me
Should print all the parts for an axis
from
in
putting
red,
this on.
but then you'd have to swap the current x-axis for those parts.
Yeah, okay, so color coding for X and Y axes. Where was this? Tinker said, should print all of the parts for an axis in red, but then you'd have to swap the current x-axis for those parts. So you're saying that the x-axis should be red. Yeah. This is something that I've been wondering. I've seen in different CAD software and in software that's used for driving CNC machines, like in Mac, Mac 3, for example, there is an origin indicator with arrows for each of the axes, and they're different colors. And I haven't actually run Mac 3 for a very long time, so I don't remember what any of the colors are. RGB. Oh, okay. But I don't know if there is a convention, and I don't think I can be bothered opening Fusion to check. My memory of the axis indicators in Fusion is that they are not different colors, it's just arrows. But if you open like Bamboo Studio, in fact we can do this right now because it's already open. So if we have a look in Bamboo Studio, say I was doing a transformation to this and I wanted to do a rotate, you see how it's got the three colors? So blue is the rotational axis, and oops, no, that's if I grab it. What if I grab it in the middle? Nope, not rotate. Okay, cancel that. Where is the translate? Yeah, move. Okay, so red is the x-axis, green is the y-axis, and blue is the z-axis. Yeah. Oh, Stephen says, pretty sure the orientation selector in the top corner, it has colors in Fusion. Oh, and Vic says, you could probably just mount the stage with 2 screws for a demo, but it will need to be propped up 3mm off the central XY pillar. Oh, okay, and oh, Tinker is saying, yes, X, Y, Z, red, green, blue. Ah. Ooh, red, green, blue. Okay, that is... Oh, okay. I want to get this right. And this is something that... Red, green, blue. Yeah, let's do it. Let's do red, green, blue in that order, because it does match. Yeah, my recollection of... what's it called? I don't know. I've gone blank. It does make sense. Let's standardize on red for X, green for Y, blue for Z. X, Y, Z, RGB. I like that. It matches what's in Bamboo. It matches my vague recollection of Mac 3 and other things. And Tinker says FreeCAD does it that way. All right, what that means is... Oh, same in OpenSCAD, says Vic. Yeah. Now that it's been explained to me that it is in the same order as RGB, X, Y, Z, it makes perfect sense. And it's super easy to remember once you make that association. So I'm going to do that. So what I'm going to do is this blue one is going to become my Z-axis driver. Luckily, that is not going to be an impediment for us today, because green will be the y-axis driver. This is the one that is going to be mounted here, and it is the one that has the threaded rod in it and is ready to go. So we can mount the green one on here, hook it up to the controller. I need to change this to a different channel anyway because it's currently on the Y channel. It should be on the X channel. We can make a little bit of progress. Yeah, why not? Why not indeed? However, to do that, first I need to finish the assembly of this axis driver, which involves attaching it to this with the nuts and the spacers and things in it. I need to put the loom bands in here for the anti-backlash and have it ready to go, and then I can just screw the whole thing onto the picker. So let's do that. Let's do it. The yellow stage, sorry, not the stage, the yellow axis driver, I will not use at all. What I'm going to do is print another axis driver in red. Then I'm going to put that in the place of where the blue one currently is, and I will move the blue one to Z, and I'll use the green one for Y. Yeah, that's a plan. I think that plan is a fine plan. Just got to be careful I don't damage that picker, which is off to the side now. All right, got myself some workspace. Red, green. This, I need some parts. What other parts do I have? Are there any other parts there? No. That is going to be used for the limit switch mechanism. So that can go off. This is also part of the limit switch mechanism. These are going to be used now. And what I need to find is the... Oh, I've already put that in. Okay. There was the... Yeah, this is the drilled out bearing thingy. That's the M3 nut that has been drilled out. There we go. Boop. As a little bearing. That is the nut that is used for the actual drive mechanism. Very good. Where are we up to? So then I need a couple of M3 nuts. I need a couple of M3 washers. So we have M3 nuts, M3 washers. I need loom bands. Loom bands are over here, courtesy of Princess Fiona. They can go there somewhere. I'll get to those. I think I had 3. I'm pretty sure I put 3 per side on, so I need 6 of those. Alrighty. Finally getting to actually doing something. So washers. How many washers do I need? I need 2, I believe. Yes, move that out of the way. And then I need a couple of, say that one and that one. I need a couple of nuts. They will be the lock nuts, or they are going to lock into each other to provide the positioning for the thrust washers, which are, well, these are basically going to be like, these 2 washers will form a thrust bearing against the face of, not that one, the face of that. Okay, so to put this together, I am going to hook loom bands. Yeah, there are instructions, I know. I'm being naughty and ignoring instructions again. So I'm going to use those. I'm going to grab another 20mm M3. I drop these into there and there, so they go into there with the loom bands over it. Then, yeah, okay, I'm going to look at the instructions. Let's look at the instructions. Oh, Vic says, a black stage is better in that there is less glare on the microscope, but I often poke a piece of white paper into the center well to give more contrast when etching. Oh, okay. And Vic says, great is
Instructions are for people that plan ahead.
No, instructions are for people who are taking advantage of all of the hard work of other people who planned ahead. Vic planned ahead. He wrote these instructions. I am just taking advantage. All right, so we're going all the way back to here. We've got the nuts in. We've done this. We've drilled out that little bearing nut. So this is the point I'm at right now. I'm going to put in some loom bands and hook them over the bolts. Then this goes through the bottom part, gets screwed on, and then there are the nuts and the washers on top, and then the little cradle thing with the thrust bearing thingy goes over it. All right, let's do this. Let's do this. Loom band time. So I've got a few loom bands. I'm going to hook some of those into here. Now, this is the point where I start, oops, this is the point where I say, all right, people, tell me a story. I want to hear what has been going on for all of you. Now that can go there. And then I can drop a bolt through the middle of the loom bands and put it in there. Okay. It's not really putting much tension on it, but that's fine. It doesn't need to be, it's just got to stop them from falling off while we do the next thing. And the loom bands have got to stop it from falling off. Okay, use TTS, please. I can't really see very much on the chat right at this moment because I am using my eyes for other purposes.
Once upon a time.
Here we go. That's the way to start a story. It was a dark and stormy night. Going with the classics. Or 'twas a dark and stormy night. I have stopped talking while I'm concentrating and thinking and trying not to screw this up. That's why I want all of you to talk. Okay, here we go. Put that through, drop it in there. Loom bands in place. Next step, doing a bit of a scroll. All right, so next step is, this is going to be slightly more awkward just on this stage because...
At John Dashwip said, a long time ago in a galaxy far,
far away. Yeah, do the classic scroll. I've got, instead of having the bolt in here, I've got a bit of threaded rod which has been glued into the end. And that means I can't just spin the bolt through with my fingers. I have to turn the whole motor, which is fine. That's not a big problem. It's just slightly more awkward. And I want to go through that. Is it that one? Yes. No. Yes. Okay, I'm going to do a quick dry run on this just to see what's going on. So this is through the bearing, then it goes onto here, screws through there, then we put the nut and the washers on top, and then we put this one inverted that way, which has got the other bearing thing on it. I think that's right. All right.
Amanda_RFT said, I am still in bed, got home at 4 a.m. from a live streaming job.
Oh, really? What was the live streaming job, Amanda? I need to take lessons.
Said, the nut bar with 2 nuts goes on the bottom.
The nut bar with 2 nuts goes on the bottom. Nut bar with 2 nuts, yeah, that is on the bottom. Yep, cool. Okay, what I'm doing is reaching in and spinning the little coupling where the threaded rod goes onto the stepper. And it's going to take me a while, but I am slowly driving it down. Once there's enough, I'll probably be able to spin it from the top, and then it'll go more quickly. Getting there. Closing the gap slowly. All right, let's see if there's enough now. Can I spin it? Oh, yes. And
It was a dark and
stormy
stormy
night. I thought I was doing the assembly. Yeah. Tinker, a nut bar is definitely doing the assembly.
I thought the nut bar was doing the assembly.
That would be me. Okay. Oh, I've got to pull that down. What is going on here? What have I screwed up? I think my spacing is not quite
Amanda
right.
underscore RFT said MMA fry.
Oh, okay. Doing live streaming at an MMA fight. That would be cool. Okay, so I have a slight issue here. I think it's okay. I actually think it's okay. I'm going to do a little bit more on this and then I'll show you what's going on. It's a spacing issue. And I might be able to fix this by changing a spacer on the motor. Okay, if we look at it from the side, we've got this little U-shaped assembly under here, which has a drilled out nut in it that the bolt goes through. But you can see that it is very close to the coupling where the bolt comes in. Hang on, got to clear the throat again. And when I first pulled this down, I thought it was going to be too tight and it would jam against the top of the coupling. But it's not. There is actually maybe a millimeter of clearance. You see on here? Yes! Sion! Welcome! Welcome! Okay, so... yeah, that's going to be okay. That is not a problem. And it is not... I'm pulling it down against it now, and it is not offsetting this by too much. So I think we could proceed with the assembly. So I think the next step is I need to...
1 millimeter of clearance is clearance.
Yeah. It's like in striking, something that my second coach, Shane, says is a miss is a miss. Which is basically, the point is, it's when you're doing slips. So if someone like throws a jab at you, oops, where's the camera there, throws a jab at you, and you slip to let it pass, the point is, it only has to miss. You don't have to have lots of movement, lots of clearance, you just got to move just enough that a miss is a miss. And it can touch you and still be a miss. Yeah, Stephen says, doesn't matter if you win by an inch or a mile, winning's winning. Now, where are we? I'm just looking at the instructions again. Okay, so now I stick the nuts on. I need the ones that I just prepared earlier. Okay, so I need to screw on, this nut needs to screw on a couple of other nuts. This one, oh, got to spin that one down a bit. And then another one on top. I'll show you the side view in just a moment. And then we're going to put the U-bar thing up over the top of it. Is that far enough down? I'll screw it down a bit more to give it clearance because we'll screw it back up underneath in a moment. Now I'm going to put these two washers on facing each other, and oh, I should have brought the mineral oil. Princess Fiona has a container of mineral oil which would be good as the lubricant, and where is it? I saw it was right here. Oh, here it is. This is my little container of spin lube dispenser, like oil dispenser. It's got like a little syringe type dispenser nozzle on it. And this is, I think, pretty much empty. I might be able to get it like a fraction of a drop out of it. But what I'm going to do is, I've got to remember to grab a little bit of Princess Fiona's mineral oil, and I'll put it in this dispenser because it's a convenient thing. Nope, none wants to come out. Okay, I will leave that for now. Drop that on. So what we have is, oh, and also I need to bolt that onto there. So those now are sitting on the bolt. So I need to bolt those on. What do I need for that? What length? Oh, that's right. They go all the way down. So I need the, like, these for it. I need to order some more of these. So that goes all the way down. And it's M3, so it's a green driver. Green. I've color coded all of my hex drivers, so I know that if I... Why is that not going in?
Said 50 millimeters.
Yep. 50 of the millimeters are required. It's not biting into the nut. The nut is down... Okay, I'm going to try a different one. I'm going to try putting it into this one. There is a nut down in the bottom of this, and a nut spinning the screwdriver. That doesn't want to go in either. If I turn it over carefully, down there you can see that there are nuts. Well, maybe you can't see. I don't want to turn it over too much further. There are nuts in the bottom there, and this 50mm bolt should be going all the way through. I'm just going to put it on its side so I can put a little bit of force onto it. Like if I take it out from the outside, there, it should reach down to engage with the nut that is in the bottom of that hole. So it goes all the way through. That should be pretty much touching the nut now. So why? Oh, that's better. Okay, a little bit of force, and then it found its purpose in life. And then I'm going to put one in this hole as well. Clamp that down tight. All right. Wonder if I should have put washers under those. Maybe I should have, rather than just have the head of the bolt bite down into the plastic. But I think it's probably okay. I don't know. What do you think? I think I might take them back out. Did I do it on the others? No, I didn't do it on the other axis. Yeah.
Picklever said, I didn't use washers.
You didn't? Okay. In that case, I am trusting the voice of the master. So I'll just make sure those are tight. Put a couple more in. There are a total of 4 of these. Screw it all down, and then we can put the... I haven't actually checked the status of the 3D print that's running. Hopefully it didn't freak out, like with a spaghetti detection or something, and so it's not going to finish in time. All right, that is now bolted on, and I screwed it down so that the position of this is essentially in its neutral position. If I put this across underneath, you'll see that the position of the bottom of that tab aligns with the bottom of the rest of the frame. It's in its neutral, unstressed position, just sitting there. But if we turn this, it'll move up or down. So I want it to be in its unstressed position while I'm getting everything else set up. Okay, that's good. And I don't need the loom bands anymore. What next? Okay. Looking at instructions, but it's going to involve putting
Printer is
these
only
on.
printing the side it can see with its single eye.
Yeah, we're going to get half a stage coming out. Where is... Did I leave... yeah, did I leave Bamboo Studio running? Did I oh, there it is. Okay, so here it is. Let's see what the printer is up to. Are you still printing? Oh yeah, it says it's running. There we go. The stage is being miracled into existence by Vic's other invention. One of Vic's inventions miracling another of Vic's inventions into existence. We're living in Vic world these days. Okay, so I need to... What do I need to do? I'm going to switch back to instructions. Those are on, so I've got to put that in, then 50mm bolts go down through there. Are they 50s? I think they are. I definitely need more 50s. I really need more 50s. I should have ordered more. In fact, temporarily I'm going to have to take a couple out of one of the stages in order to do this. Because when I ordered the 50s, I think I said this on a previous stream, I knew that I needed 50s for the drive mechanism. So I ordered a 10 pack of 50s thinking that was all I needed, and I'd have 3 that I use and 7 spare. Turns out you actually need quite a few 50s per stage. I mean per axis. So I don't have enough. Oh, hang on. Yes, I do. Yes, I do. Because I've got all of the 50s. Oh, we are saved, people. Another one of those things where I did not...
ordered a 1,000 pack.
Yeah. Yeah, you can use the 50s with the shank for the deep ones, Stephen. Yes, that is exactly right. Here we go. Look, I've got these other ones. These are perfect for the mounting. In fact, I am going to bring back these out and save the full thread bolts. So there's one of the full threads. I'm going to replace it with a half shank because I've got plenty of the half shank 50s. And in fact, I'm going to swap all of these, which means that the day is saved. We have enough. Oh, that's nice. I do not need to be placing another order with Amazon to spend $15 for a pack of 10 bolts, which is not very nice. It's a lot. It's a lot. So now I've got, yeah, now I'll have plenty of spare full thread 50s. And I can fully bolt everything else together. That is a happy discovery / realization. Come on, TTS, entertain me. You think that I am here to entertain you, but you are here to entertain me. So, tell me. I've moved on to 60, says Tinker. Okay, so loom bands are still there. Those are now bolted in place. I now need to get this on by sliding it down onto there, but it also needs to hook the loom bands. Okay. And by pulling up on that, okay, it's not going to come up because that thread, sorry, I'm just thinking all of this through. I do not want to stuff this up any more than I am already going to stuff it up. So I need to pop the loom bands over that. Whoop. And then do the same on the other side, and then I can pull it. So I can pull that bolt out now. Can I lift it high enough? Yes, I believe I can. Then I need to get these loom bands. Take that bolt out. Pop the loom bands over this tensioning frame. And then I need to pull the whole tensioning frame up.
Have you put a little grease on the drive thread?
I have not. I tried to do that a few minutes ago with this, and it is empty. That's what I was talking about with the mineral oil that that Princess Fiona has, that I was going to take a little bit of, and I failed. All right, so now we've got that fitted over there. And what I can do is run these up. So I'm going to have to lubricate them later. I will put a little bit of, like a little drop in there, in between the washers. So that goes in there. This rotates. So these two will be facing each other through the frame. And then after I've done that, I can drop this on. So once again, I think I need 50s for this. So I've got a couple of the shanked 50s, which go, oh, missed. So I've got to align the bottom part and drop it down through there, through there, and into the nut that is in the bottom of this. And then I learned...
Put the two 50s in the top nut bar before you tighten the two nuts.
Yeah, I will. I'm just getting this one started so that it holds things kind of aligned. And then I'm going to put that one into there.
Never mind H's onto it.
And... yeah. That one, bring it down. So I'm not totally bedding them down, I'm just getting them so that they're close. And that can all move a little bit. It can sort of self-organize itself, sit in the center. Just make sure I can still turn that, which I can. Looking good. Okay, so now I'm going to tighten these ones down. And then I will drop that tensioning bar over the top, which will increase the pressure on the loom bands. Looking good so far. So I need to get this under the loom bands and onto the top here without killing everything. All right, I'm going to use, what am I going to use? I think I will use that. Yeah, why not? That'll do. So I'm going to pull the loom bands up to give myself clearance, pop that through and hook it. And then I've got to do the same on the other side to get these ones up on top of that. So go through, lift it up and over. It feels like I'm going to break them, but they're probably stronger than I think. There we go. So now we have the loom band anti-backlash mechanism pulling it up against the thread. And I'm going to see if I can sit this still. If I turn the thread, I can move the mechanism. But first, I need to do up these nuts against each other, the lock nut mechanism. That should be reasonably well supported. I'm just thinking about whether I will damage that in this process, but I think it's okay. How am I going to do this? I'm going to use needle nose pliers and hemostat, I think. It's probably the best thing I've got for getting in there. I need to turn these two nuts against each other Yeah, so screw that top one up until the thrust bearing essentially is just against that face. And then I'm going to hold the top nut and turn the bottom one. So I've got to lock that one in place and turn the bottom nut to jam up against it. Turny, turny. That's it. I think that's pretty well locked on. So now we've got that thrust bearing up against the bottom part there. Okay, so now if we drive this stepper, we can move this axis. Groovy. This is part of the assembly for the limit switch. It's just sitting there. I put it on to provide support to these two bars while the rest of it was being assembled. So that can come off now. It doesn't hurt being there, but what I need to do is finish the assembly of the limit switch using this as well. So they clamp together, and you can see the little holes there where where this comes out, which is the little springy wire that will be used for making the limit switches. Yeah, all right. We have a G green Y-axis stage. Oh, Y-axis driver, rather. All right. Back to here. And now we should be able to attach this. Where does it attach? I believe it attaches right there. So this point is where the stage will mount. On this side of it. It comes down, hooks over, comes down on the outside of that plate, and then we bolt through. So we need bolts through there and there into captive nuts in here, which are not there. I better do that. Yeah, I need to put those captive nuts in. That is something that I overlooked previously. Let's fix that. Yes. That needs a bit of cleaning out. I think that's a job for the scalpel.
Coffee has arrived.
Coffee? Oh, it hasn't arrived for me. Well, yeah, a coffee arrived earlier, but I could do with one.
Some squirrel ran off with John's nuts.
Yeah, no. I know where my nuts are. Cleany, cleany. I'm not sure if I need to put these in. So there are 4 captive nuts going in here in this part of the axis driver. And also I need to check whether they're in the picker, the matching ones. Did I do it on the other? Sticking my head in the way. No, I didn't. Now, Vic, I don't know if these are necessary. You can answer this question. I'm sorry, I'll ask the question properly in just a second. Once I clean this. So, what you can see, looking down from the top, there are these 4 places where captive nuts can go in. 2 of them are for bolts coming up from the bottom, 2 are from bolts from the top. So, 1 nut is there, which would be for a bolt coming down from the top, holding this on, and 1 is from the bottom for a bolt that comes in from the picker to hold this in place. The question is whether these are actually necessary, because I think I'll do it. Yeah, I think I'm going to do it. So my question for Vic was whether I really need to put those bolts in, because this feels fairly rigid already. Hang on. Oh, I do need to have a drink handy. I don't have one anywhere nearby and my throat is complaining. I think having that clamped down at that point, it's clamped down there, having it clamped down here will increase the rigidity slightly. So I think I'm going to do it. I'm going to put nuts into those and bolt that down. It kind of feels like it's not necessary, but it may help. Now, the way I got these nuts in last time to stop them twisting as they go in was to push them with the pliers with the jaw slightly open. There we go, clicked into position. This is, yeah, I'm going to do all of the, try to do all of the things Vic recommends.
At Tinker001 said, TTS is randomly ignoring Vic.
Oh, is it? That's strange. Where is TTS? Cast note. I'm just going to check what it is, why it is ignoring Vic. Vic said you only need the 2 bottom nuts. Oh, blocked. Bad word detected. Yeah, I can't even manually activate it. I think because it had the word nuts, perhaps. All right, I'm not going to put the top one in then. I'll leave that one off. And bolt this. Yes, so I need to check. Does the stage have the corresponding? So those 2 bolts that go through there are the ones that go into the ones I just put in. Oh yes, there is a nut in there that you can see. That is going to be bolted in from the top. Oh, that worked. Okay. Now, what length do I need to get into that? Maybe
Bottom.
about a 20. Yeah, I think a 20, so I'll grab another 20. So I need a couple of 20s to go in from here. And then from the top, what do I need? Yeah, more 20s. Hang on, that's not a 20. One of these is like a 16 or an 18. Oh no, those are 20s. This one is something longer. That's a... Would this be long enough? No, okay, the 20s aren't long enough. I need to go one size up. I'll go for 25s. There we go. Oh, that badoink was the printer finishing. Here we go. I will get this one in just loosely to stop it all flopping around. And the other one on the bottom. Come on, bite, find some thread, there you go. And then this one comes in from the top. And then we've got another one below this. It's getting to the point though where I need to be cautious about how I pick this up and move it, because I do not want to break anything. Again. Now, why is that not going in? Oh, it is. It's slowly going in. It's working its way in. Okay. Now I can tighten these up. Ah. And tighten these, and then we'll have the Y-axis driver fully mounted. There we go, nice and secure. Y-axis driver in place. X-axis down here to be replaced by a red one, Y-axis driver here, and what should have just finished on the printer is the stage. So then we can put it on here and attach it to that. And then we can try driving the Y-axis. What's the time? 11:42. Yeah, we'll get it driving in X and Y. I'm going looking at the printer to grab the stage. Thank you, printer. Thank you for your service. Oh, it's a fine looking stage. I need to glue the magnets in. I need to put the UV LED in as well. And just as a check, yes, it fits and it aligns. Very good. All right, we have a new stage. I just need to clean up these holes a fraction because it was printed on this face and these holes have got little bits of duvalaki in them. So, deburr. Yeah, this gets mounted upside down. Right, I'm not going to glue the magnets in right now. I'm going to just get the axis driver, and I'm not going to glue the UV LED in right now either. I'll get the axis drivers working. So, maybe though what I should do is bolt this down. Oh, this needs, what I'm looking for, this needs a little bit more deburring. So I'm going to need some very short bolts to bolt this down. Maybe some 6mm. Still got to clean this up a little bit. And for now, I don't need to do it up properly because I'm going to have to take it off to put the UV LED in there. So I'm just going to put in some, I think maybe 6 or 8mm. Is 6 going to be long enough? I think it might need 8. And I'm going to use, instead of using cap head, I'm going to use a thin-headed Phillips head. So these are like a flat, oh, it's hard to see. It's a Phillips head, 8mm, with a very skinny flat head. And I think those will be just right for this purpose. Let's see how far they come through the stage. Ah, nothing broke. Yep, so they stick through the stage that much. Just right. And now I need a screwdriver. And I do not want to push down too hard on this. Oh, that's nice. It just fell into place. Yes. Okay, so I'll just put a little bit of tension on those to make them stable. And now we have a Y-axis driver. So I need to put bolts through. Red, blue, green, black, red, blue, green, black. All right, I'm gonna, sorry, what I'm doing is unscrewing the motor driver. So I'm disconnecting the tiny G from this because as I move it around, it's dragging the motor driver board around and there's another stepper attached to it and it's all a pain. So with that disconnected, it means I can move this without dragging things off the table and potentially causing big problems. Oh, it's looking like a complicated structure now. So what I need to do is, you can see on here, this is the stage which needs to be screwed onto this axis driver. So I need 2 little bolts that go through there, and they will be
At Tinker001 said, maybe TTS thinks Vic Oliver is a bad word now.
Yeah, maybe. So I need, yeah, I think 10s will do. A couple of 10mm bolts coming through here into the nut in the axis driver. There we go. And oh, nice. So now we have the X and the Y axis both connected to the stage, which I can physically push around just because I can flex things that would not normally flex when they're being moved by the axis drivers. I think the next thing to do is to hook this up and drive it in X and Y axes. We should now be able to, yeah, so we still don't have homing and we don't have the Z axis. What am I going to do? All right, I'm going to put this on. Here we go. I'm going to put the microscope on and feed it to the computer so that we can see how we're going to do this. What I would like to do actually is put the calibration slide on here, and maybe what I'll do is, to keep it flat, I'm going to clamp it between a couple of regular microscope slides. I have a packet of glass microscope slides here.
Judging by the colours, looks more like Z and Y axes.
Yes, that's correct. Who said that? Tinker. Yeah. The blue I'm going to take off and I'm going to use that as the Z axis. But to do that, I need to print a new X axis in red. Which I don't have. So I will get the printer doing that off stream. In fact, what I'll probably do is get it printing this afternoon. Before I leave, I will start it printing, and then when I come back, it'll be done. All right, so here is a glass microscope slide. Oh, in fact, I'm going to put 2 on just because of the area of this. So 2 glass microscope slides, they're sitting on there, you can't even see them. Sit the calibration thing on top. I wonder if I should put a piece of white paper under that. I have a feeling I should. Or a yellow post-it note, maybe. What else have I got? Yeah, yellow post-it note. This'll do. That'll make it visible under the microscope. So yellow post-it note, then 2 glass slides, and then I'm just going to sit the calibration slide on there, and I'll move it so that it's, oh no, I can move the camera, that's okay. Yes, that'll do. Oh no, what I'll do is I'll move the microscope slide so that the reticule, that little cross thingy, is visible, sort of in the center of the stage. And then I'll put another microscope slide over the top, purely as weight to hold it down. There we go. Now I can move the camera and put it directly over the top, and tension that up. Yeah, I might as well. I'll hook up the microscope before we hook up anything else. So I'm going to hook the microscope up to my Mac, and then I'm going to What'll I use? QuickTime, that'll do. QuickTime and new movie recording, which gives us a view out of, haha, not that, I want to capture, what? Why isn't it seeing it? QuickTime is not seeing the microscope. Phone camera, why not? What if I unplug it from there and plug it in somewhere else? No? What if I plug it into that port? Can QuickTime see it? Yes, there it sees it. Okay, digital microscope. And I'll bring it up on screen. Now, what I will do is mess around with the focus on this and see if we can get, oh, here we go. It's getting closer. There we go. There is the, I overshot. Back it off a little. So that is Paul's calibration slide. I'll move it a bit so that it's more centered. And I'll rotate it. I need to rotate the camera. Okay, so that is more like that. That is actually straight on the stage. It's the camera that's twisted. So I'm going to rotate the camera. To get it approximately horizontal. Something like that. That's pretty close. Fix the focus. Woohoo! There we go. Okay. Now, so we're looking at tenth of a millimeter increments there on that graduation. Those little dash lines. And now, next step is I need to connect. Just got to think about this. I'm going to switch back to overhead view. Yeah, the focus is slightly off here. Where am I going to put this? Got to figure out where it's all going to fit on the bench because it's getting a little bit awkward here. I need to put, so that's the x-axis. I want into that channel. This is the y-axis, which I want to put into the motor driver 2, and that will then. And the thing is that we've been testing the x-axis with the y-axis command. So the configuration that is on motor driver 2 right now for the y-axis is correct. That is the one we've been using. I've got this classic situation where, as I've been doing stuff, everything accumulates on the bench, and now I can't find anything. All right. Got to put this motor into channel 2. So red, blue, green, black. And I'm doing it backwards with the connections facing away from me. Extra difficulty. Bonus points for difficulty. Come on. I can't even see where the slot is, so I'm trying to put the wire into. And there. Okay, now I'm going to remove this. So this is the yellow driver. Yes, the yellow one, I'm not going to use at all anymore. So I need to replace this with the x-axis motor, which ultimately is going to be replaced by the red motor. It's all very confusing, but we'll get there. We'll get there. All right, we are minutes away from driving this in both the x and y axes. So starting from the left this time, I'm going to do black first into B2, then green, I should put ferrules on these. But I also need to set up a base. What I want to do is make some kind of maybe like a big acrylic base, and I could laser cut some holes to mount the different things into it. Maybe screw the pica down to oh, I bumped it. Screw the pica down to the base and screw the tiny G to it. Make it all so that I can pick the whole lot up as a unit and know that I'm not going to mess things up by having something fall and then pull the RepRapMicron off the bench and dump it on the floor. Because if there is a way to throw it on the floor, I will do it. I need to protect myself from myself. And red. Yeah, anyway, my point was I will need to figure out cable routing.
To be able to get the pica under the binocular microscope.
Oh, okay, that's a good point. My assumption is that it was Vic who said that, because it is someone speaking from experience. Was it Vic? Yes, it was Vic. Okay, now USB. I need USB into the tiny G. I need power into the tiny G, which I will inject from a lab power supply. So go gadget lab power supply. Where's a cable? I need a cable with a 2.1 mil jack on it to go in here. And what do we need? 12 volts? Yeah, 12 volts is good. 12 amps? Yeah, why not? Okay, it's actually powered up now. So we've got power on the tiny G. We got both X and Y axis drivers connected. I'm just going to move this slightly to bring it more under the view. And we should now, at this point, be able to pull up the software, like the serial interface on the tiny G, and drive both axes. Let's do this. We are right there. We are right there. Okay, so this is the view of the reticule. Maybe what am I doing? Cool term. I want a serial port onto that. Okay. Just plugging it in. Let's see what we can find. Options, port. Oh, yeah, there is something weird going on with the ports on my external dock. Rescan. It's got a couple of different USB hubs inside it. I'm going to try to plug this into a totally different USB hub. Let's see if this works. Rescan. Yeah, there we go. Now we've got the serial console. We want 115. We want terminal to be in line mode and connect. And let's see how it's configured. Yep, there we go. Okay. What we can do is have the we've got the camera view open in the background. We've got the serial interface in here. So let's pull up the full config and let's have a look at the config on motor 2. That's the one that we've been using. So we've got 0.9 degrees, 216.92 millimeters steps per revolution. And let's have a look at the config on motor 1 and make it match so that we've got the same scale. It's possibly going to need more tuning, but this will be a starting point. So what we can do is say 1 TR, so the 1 travel resolution is 216.92 millimeters. And we're also going to look at the X configuration and compare it to the Y configuration. Y? Yeah, because we know the Y-axis configuration is good. This is the one we've been testing with. and I'll make the x-axis the same. So x velocity maximum, I'm going to take it up to 10,000 millimeters a minute. That needs to be 8,000. Okay, so let's do xvm equals 10,000. And we'll do x feed rate maximum equals 8,000. Do you usually... at this magnification, the 0.5 millimeter marks are the same as the spaces. Do you use the leading edge or what? Yeah, I could. That's right. Work with a picker. I have 3 screens here. What else do I need to change? So we've got travel min max don't matter. We've got jerk max, jerk homing. They are the same. They're unchanged. Search velocity, latch velocity are unchanged. Latch back off. All of that's going to become important once we do the homing, but at the moment we do not have that. So we've got X switch min, X switch max. Those are not relevant yet. So travel, X maximum travel is the same. Yeah, okay. So looks like we've got the X and Y axes the same now. So let's have a look at, I'm going to do a recomparison of motor 1 and motor 2. Just to make sure they're the same. So motor 1 is on the x-axis, motor 2 is on the y-axis. That's correct, 0.9 degree, 216.92 millimeter travel. We've got 8 microsteps. We are running power on in cycle, which is fine. We don't need to have it locked in position at this point. And in fact, it'll be interesting to watch through the microscope as the motor is relaxed and the motor driver releases it, and see if we can see any jiggle in it. Of course, the jiggle could be happening at a scale beyond what we can see on the microscope, which could still be a problem. All right, so the motor configs are now the same. And we'll have a look at the X and Y axis configs. Again, oh, hang on, X feed rate is, I thought I changed that. Okay, so X feed rate maximum should be, maybe I changed it on Y. I set it back to what it was. So X feed rate maximum equals 8,000. And so we've got travel max, and all of those are the same, 5, 1, etc.
At Paul_Schultz said, the microscope should be able to zoom further.
Possibly if I took off the shroud, because at the moment it is almost touching the surface of the slide. It's got the clear plastic shroud around it, and that is like 2 millimeters off the surface. I'd need to bring it down lower to get more magnification, I think, unless I'm mistaking the way this microscope works, which is very likely. All right, now let's try a move. I'm going to try moving the x-axis again, because that is the axis that we know was working before. So let's do...
At Vicklerbert said, zoom in with QuickTime.
Zoom in with QuickTime. Oh, okay. Let's see if I can do that. Zoom. Oh, that just went to full screen. View, can I zoom, zoom, into full screen? Looks like I can't, maybe? I can take it full screen, but then we can't see the other window. If I do zoom, increase size, decrease size, oh, that's the window. Zoom, actual size, no, I can't. Oh, the other zoom mode is...
At Paul_Schultz said, yes, other zoom mode is at the other end of the focus stop.
Other end of the focus stop. Oh, ooh, okay. I'm going to leave this on screen, and I'm going to slide over to here, lock, unlock, and up, down, and where is it? Because this this is just brightness. There is focus, which is this. There is a physical move up and down, so I can, that is actually hitting the glass now. It is pushing down on the stage. So I've raised it just off the stage now, and then I'll refocus. Yeah, I don't see any other way on this microscope to be able to zoom it. Oh well, anyway, that will do for now. Oh, no, that focus can be improved a bit. Let me mess around with it a fraction. Touching it moves it enough that it screws it up. Come on. Come on.
And Paul_Schultz
Nice.
said, okay, different from mine then. Turn off fit to window on QuickTime.
Okay, turn off fit to window. Where is fit to window? And a full screen float on top. DIY! DIY is here. Playback speed, audio languages. Spatial video. Zoom. Oh, fit to screen is turned on. No, okay. Fit to screen is decrease size? No.
At Vicoliver said, window menu,
Increase
fit to
size.
screen.
Yeah, it's on. And if I select it, it just stays the same. Anyway, that's not important. Let's make it move. What does zoom do? Zoom. Yeah, okay. Stuff it. I'm going to leave it like that, and we are going to make it move. Let's make it move. Okay. Let's go G0X. Oh, this is set in microns now, isn't it? I got to remember what I was doing.
Vicoliver said, oh burger it, move the thing.
Okay, 1. I don't think we're actually going to see it do anything. Oop, it moved. Now I'm going to say 0. Okay, very good. So now I'm going to say 100, which is 100 microns. It should move one of those increments, I think. Oh, look at that. And now if we go back to 0, so look at the edge of this. I'm going to move the edge of the window to be just touching the left edge of this line here. And now I'm going to tell it to go back to 0, and it's going to move sideways. And it ends on this edge. Nice. Okay, so that is moving 1 micron. No, sorry, it's moving 100 microns in the x-axis. Let's go y-axis. And I'm going to start with 1 in case I screwed up the units again. Here we go. Ooh, okay, now back to 0. And I'm going to now move y 100 microns. And oh, look at that. So we moved up to 100. It's even going in the correct direction. Or
Calibrated.
Is it? Back to 0. Moving back down. Moving back down. Okay, I'm going to... Yeah, let's do some calibration on the... which way is this? It's going to move that way. If I move it 1 millimeter, I'm going to move it... So that is going to move... Hang on.
Wood. Now
way?
make it do a circle.
Yeah. All right. Now that is to 0. So if I now move it to minus 1,000, so minus 1,000 microns, that is 1 millimeter. It should end up on the edge of this line. So let's see how accurate that calibration is.
The sound of it doing a circle will be cool.
Haha, yeah, it would be. Ooh, slows down. It didn't quite make it. It almost made it. It was close. If I
And John Dashwib said, I feel a hello world coming on.
Ooh. I think I could turn up the rate of acceleration too. The acceleration is very slow right now. Oh, and it hasn't
At
quite got back to it.
Tinker001 said, it yelled wee.
Yeah. Yeah. Okay. Is that zeroed? I think I zeroed it. Yeah,
Movement will be sort of backwards because the probe is static.
Ah, yes, true. Yeah, so the probe is static and then we are dragging the thing around underneath it. So moving in the positive direction means moving it down. That does make sense. So if I say move to Y100, which is moving the probe up, then we want the stage to move down. And it's backwards. Okay, so I need to invert. I'm going to take it back to 0. I need to invert the y-axis direction. So how
DIY seems to want someone to ask questions.
How is y set up? Oh, hello DIY. I won't say more. Okay. From what are you apologizing to me for? No, access mode standard. Is there a? Can we do an inversion? I mean, I could just swap 2 wires. That does the same thing. So which means, yeah. All right, let's check if, with this knowledge, let's check whether the x-axis needs to be inverted as well. I might just swap the wires on the steppers. Oh, I wouldn't let you watch YouTube. That is cruel and unusual punishment. So I'm going to do G was X. Okay, I'm going to move X by 100 microns in the positive direction. Thinking this through, we want the stylus to move to the right in the positive direction, which means we need the bed to move to the left. So let's see if the bed moves left when I do this. No, it goes right, which means both of the axes are inverted and G0x0, let's send it back to 0. So what I could do is, if we look at the config for motor 1, polarity, I could change it in here, but they're both reversed. I'm tempted to, I think what I'm going to do is swap 2 of the motor wires so that we can leave the polarity as normal in here, I think. Oh, JISC says G03, X0, Y0, R1.0, a circle with a radius of 1 millimeter at midpoint 0. I'm not sure. Oh, I've got someone knocking at the door. Good. Oh, Gavin's here. Hello, come on in.
Hello.
Yes.
You're still moving things, are you?
Yes.
Keep moving things. You're
Okay,
doing a good job.
we'll keep moving things.
Sorry about that, guys.
Yeah, okay, I don't know if the tiny g is going to recognize a G03, but, oh yeah, it would be a radius of 1 micron because this is calibrated with 1,000 to 1 ratio. So the numbers we are putting in here are microns. So what I would do is G03, that blah, 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 are 1,000. Yes. So then, but I want to reverse the axes. Or do I want to, that's okay. Or do I want to do it in software or do I want to do it in hardware? I'm leaning towards fixing it in hardware. Yes, I'm going to fix it in hardware. All right.
Would you like a drink?
Excuse me.
You said you wanted one.
Oh.
I'll get you something out of the fridge.
Yeah. Can you grab me a solo, please? There. Yeah. Thank you. So what I'm going to do is reverse. I'll reverse black and green for both motor drivers, and that should. So I'll put green on the end.
Hi, Gavin.
Hey guys.
Who was that? Crispian says hi, Gavin. Yeah.
Hey guys. That'll be $2.50, John.
No worries. I will put it in the. I'll leave it on the fridge.
That's it. It's your fridge. It's fair.
I'll put it into my retirement plan.
You know this
big
is
thing.
officially small, right?
This is officially small.
I can hardly even see it. More or less read it.
The slide.
The whole
on
thing.
Yeah.
It's scary small.
It is very small.
At Grandmeisel said, don't get caught up on the direction. Every time you reconnect the motors, you have a 50 chance of changing it unless you have a wire order.
Oh no, I'm going to have a wire order. Definitely. Once this is set, I'm going to keep this consistent. Because I don't want to, I don't want that 50-50 chance. I want to predict it and not not have it moving the way I do not expect. Okay. So this is why I want to solve this problem now and get it so that it does what I expect. So now if I do G0x100, it should move to the left by 100 microns. So let's go. Yes. And I'm going to re-zero that. And now if we do y-axis, this should move positive, this should move down. And it does. Cool. Let's re-zero the y-axis. And let's do the 0, 3. I don't know if this G-code's going to work, but let's find out. Oh, yeah. Princess Fiona just said, for the record, I want to hear the story of
Now,
Vic's
a
Nerd Brag
circle.
about the Hackaday What's That Sound competition. Yeah. Now, 0, 3, where is this? X, 0, Y, 0, so that's the center of the circle. R, I'm going to make it 100 microns. R, 100, and we'll see what happens. Oh, feed net rate not specified. Okay. So for any move other than a G0, we need to specify a feed rate. I have no idea what feed rate to give it. I'm just going to say 1,000, and we'll see what happens. Nope. End point is starting point. Oh, arc specification error. All right. So G03 must be an arc move. Calibrated. Okay, here we go. F0.2. G03, X0, Y0, R100, F0.2. Yeah, but that's not the feed rate is not what it's complaining about. It's saying that it's an arc specification where the end point is the same as the starting point. So G03 must be an arc move. Oh, G02, okay. Is G02 a circle? And Y.2 is the feed rate. That seems incredibly low. But let's find out. G02 is for radius. Oh, radius, okay. Nope, it says arc specification error. Endpoint, same as starting point. Yeah, so what we're talking to here is a tiny g. And the tiny g has a subset of G code. There are so many possible G codes. And it could be that the tiny g simply does not support the circle movement as a G02. Arc specification error. Okay, let's just do another move that's going to go, geez, I'm just going to make sure that is zeroed. Let's do a diagonal move. Sorry, G02 is for clockwise and G03 is for counterclockwise. Oh, okay. Yeah, so they'll both have the same issue. Let's move to
Standards are
X.
wonderful. Everybody should have one.
1000. Oops. Yeah, we'll move to X1000, Y1000. So this should make it move 1 millimeter diagonally. And it should move down and left. So I'm going to set the window right here. See this intersection of this window, the 0 point right there? This should end up here, where those two lines intersect. And let's see what it does. Go! Oh, we've got a diagonal move. Oh, you can see that the x-axis calibration is off now. That is definitely going to need some modification. And I'm going to move back to 0, G0 and Y0. Woo! Aww. All right. So there is a little, yeah, there is a little calibration required, but I think we are on track. I'm going to move to X100. Oh, something that would be interesting. Okay, I'm going to move to 1 millimeter on the x-axis. So this should butt up against the... Okay, I'll explain what I'm thinking here. I want to force it to be offset and then drive it in the other axis and see if it remains linear. In fact, I'm going to take that out to 2000. So we're going to be 2 millimeters offset in the x-axis. And in fact, we're a little bit short. So I'm going to take it to 2100. Should get us about there. Just eyeballing it. Oh, look how good that eyeball was. So now what I'm going to do is move it in the y-axis. And we are going to see if, I'll move it 0.5 millimeter, if that line stays vertically aligned with the edge of the window. Which, what this is going to tell us is whether the axes are decoupled from each other. And we can move in one axis without moving in the other. It's looking pretty good. So we're now moving, in fact, I'm going to take it up to 2 millimeters. I was going to say centimeters. No, millimeters. It looks like there is a slight deviation happening. That could also be because of rotation of the camera. So I may not have perfectly rotated it. So that could be part of it as well. So we're sliding along that x-axis marker in the vertical direction. I'm going to take it back to, I'm going to take x back to 0 and then slide it down on the y-axis. And I'll get that ready. Y0, and we'll slide it down that axis marker. Vic says, yeah, one of those axes is a little wavy. Check the drive screws are central in the nut bars. Oh, okay. Yes. All right, so there's some tuning I need to do. But we're doing okay. We're getting there. Groovy. I need to print. Yeah, okay. It's time to wrap this up. We kind of got to a semi-useful place. thanks again to Paul for sending this calibration slide that you are seeing on the screen here. And of course to Vic. The arc's radius, just said XY, the target coordinates at the end of the movement are the arc's radius at which the machine will move from the current position to the target position. Okay. Yeah, so thanks to Paul for sending that. Thanks to Vic, of course, for this, all of this schmozzle. It's all his fault. And yeah, thank you all for coming along. I'm gonna print the X-axis driver in red and swap it out, and then the blue one, which is currently on the X-axis, can be moved and become the Z-axis driver. Oh, look, we can see Gab's phone there.
Oh, sorry.
No, it's okay. Oh, no, it's not. It's not on the stream. I just realised. I'm seeing it in the overhead camera,
I'm
but
just
it's
taking a note of how small this is.
yeah, it is very small.
It's incredibly small.
Yeah.
Scary small.
And the thing is that this is what we're doing here is gross movements because we don't even have enough magnification. The cool thing is if I go G0 like X 10 to move 10 microns, it moved a little bit. With
No, it didn't. I watched it.
moved it back. We can just see it moving
Nothing
on.
happened.
We can just see it moving on the microscope, but to the human eye, that
Do you
is
see that water molecule float by?
that is imperceptible. Yeah. Yeah.
Okay. So we've got a guy who has made circuit boards that go into space,
Mm-hmm.
has made printers, and now he's making something infinitely small. Is that what we're talking about here?
Oh, I'm just copying from Vic.
Being Vic. So
Yeah,
Vic's
yeah.
A real legend.
Ye-
So
Yeah, there's no question of that.
scary. Scary.
Yes.
It has been awesome again.
Oh.
Thanks all for coming, and thanks Jono for hosting.
Ah.
Guru all.
Yes. Thanks, Crispian. It feels like there was something else I was going to say before wrapping up, but I can't remember what it was. I don't know. Ah.
Survived 2.5 hours. We've done well.
Yeah. Survived. I'm conscious still. Okay. Thanks everybody for coming along, and yeah, go and build something awesome. I'll see you later. Bye.